Hi, everybody, and welcome to Platform 2024. I'm Craig Terriak, Vice President of Product Management at Scale Computing, and I'm joined today with Dave Dimlow, the Vice President of Product Strategy. We're here today to talk about SE Platform and multi-cloud management. And as part of this, we're going to really quickly touch on the role of the cloud, hit on a little bit about edge platform user personas, and then go through some of the major cloud providers and how Scale Computing Platform works alongside those. Now, starting here with the IT service spectrum, there's actually a slide that we commonly will have about edge computing spectrum, and with this exact same image, in fact. But I really wanted to draw attention to the fact that this is about the IT services that overlay the entire spectrum and not the edge itself. The IT services that we're typically talking about, when we're focused on edge computing, we live in this world where it's the physical device, it's sitting on premises, whether it's in a regional data center all the way down to the far edge. But the IT services that are being provided on top of that span this entire spectrum. So, there are certain applications within, if you're an IT director within your environment that are 100% cloud-based. Good example being email. We're all thankful for the fact that nobody has to host Exchange anymore. We just use Microsoft services and it all works. There are other services that, think intra-ID or, just identity and access in general, or remote access and monitoring that really have to work, whether it's the cloud, whether it's the core data center, or all the way out to the device edge. And those are really what we're here to talk about today. I'm going to, on the next slide here, just talk briefly about, SE Platform. Our distributed edge infrastructure, as you know, it provides a platform for running the legacy virtual machines right alongside some of the newer native container type of applications and provide high availability. It's kind of all the things we always talk about. Almost all of our messaging, though, is directed almost exclusively at the IT department themselves. And Dave, if you could advance, you'll see that the benefits that we provide for this team are all around simplifying how you manage, how you deploy, making sure that you have whatever monitoring and policies set up so that you can stand up this infrastructure quickly and make sure that the applications that you're deploying on top of that have all of the inherent capabilities that these clusters provide. What you've started to see us talk about in the last, I would say, year or so is empowering these infrastructure teams to go out to the application teams and say yes. So whatever tool set they've decided on, for the container lifecycle management of choice, we want to be able to say, yes, we work right alongside that. So some of the functionality such as Cloud Init that we've developed, some of the functionality like the Red Hat certified Ansible collection, this is what is allowing the infrastructure teams to go to those application teams and say yes. Those services, whether it's, in these cases, some of the container lifecycle management tool sets that we talked about here, those are not the only tool sets that we have to be able to say yes to. It's, basically all around how do we make sure that SE Platform works alongside whatever tools have been decided on within the IT team, whether it's on the application team, either internally or externally, or the IT team themselves for, the services they want to provide within their organization. So we'll start here with Microsoft Azure, and Microsoft Azure has all sorts of different services they provide. And yeah, Dave, if you want to start running down the list here, we'll talk about how we work alongside these.
Sure. Yeah, we'll go through some of the cloud specifics, and I think we'll spend probably the most time on Azure, just because they have a lot of different services, and any of the services here that we don't get to touch on generally are available in multiple public cloud providers, and in some cases some specialized cloud providers. But generally they tend to fall into kind of two categories. One is how you can extend on-premises infrastructure applications and services onto a public cloud, such as Azure in this case, for things like disaster recovery, backup, storage synchronization, so on and so forth. And then the other is how you can leverage public cloud, Azure in this case, to centrally manage and monitor. So similar to how we, our Fleet Manager based product is cloud hosted, giving you visibility across all your on-premises gear. So we'll walk through some of the kind of key services. But basically they do fall into authentication and identity, remote management. Azure Arc, we'll talk about how that works, storage, application access, and then most cloud providers, and where we see a lot of these hybrid cloud applications, tend to be in an IoT space where you may have on-premises data collection, doing local analytics, sending stuff up to a data lake for centralized processing and so forth. So let's jump in and walk through. So Azure Entra ID, which is formerly known as Azure AD, For one, it's a great cloud service to let you synchronize any existing on-premises Active Directory accounts and domain controllers to make them centralized and cloud-based. So, as opposed to them being locked inside a private network behind a VPN, there are synchronization tools that allow those same authentication servers to become cloud-based by synchronizing them with Azure Entra ID. Another key aspect of using that in the scale computing platform is using Entra ID as an OpenID Connect provider. So using it as a single sign-on source for access for all your administrators, all your teams, to be able to access not just a Fleet Manager account, so you can use Entra ID accounts to access our Fleet Manager centralized console, but you can also set up Entra ID to provide role-based access control for individual scale computing hypercore clusters. You can leverage the full role-based access control, so you can have one place to manage accounts, one place to manage roles, and then set up single sign-on to any number of hypercore clusters. So that's a really key piece to centralize your authentication. Once you've done that, there's a couple unique services available on Azure that are designed to let you manage on-premises infrastructure and applications as if they were other Azure resources. So Azure Arc for connected machines for servers lets you centrally from the Azure console manage Windows and Linux workloads that are even running on premises. So just like you could with an Azure VM that you're paying, by the second to run on Azure, you can install the connected machine agent onto your Linux or Windows workloads. And then from the Azure console, have centralized management of things like updates, policies, gathering logs, analyzing logs, remote monitoring, enabling security, monitoring policies, and even remotely accessing resources from an administrative standpoint without having to VPN into remote sites. So there's services through Azure Arc like being able to use OpenSSH or even fully access Windows Admin Center, which is their cloud-based or web-based portal for managing Windows servers through the Azure console, again, without having to have that on-premises connection. And this is what it looks like. So this is a screenshot of my Azure portal. You can see here, I'm seeing all my Azure Arc virtual machines. And all of these systems here are actually running on premises on hypercore gear, various roles, various, operating systems, Windows, different versions of Linux. I can set up tags, maybe to identify what hypercore cluster they're on. But then from that, they're monitored centrally from the Azure console. I can remotely, as you're seeing here, SSH into them. So you can load OpenSSH for Windows, or certainly it's available on Linux machines as well, and remotely connect into those for monitoring. A similar kinds of capability comes with for managing containers, and specifically Kubernetes orchestrated containers, and that service is Azure Arc for Kubernetes, and it installs onto a Kubernetes cluster that you have already deployed onto your hypercore cluster. It can be a single node cluster. It can be any CNCF certified Kubernetes, so K3s, OpenShift, Microshift, just about any Kubernetes distribution you could want. It installs as an operator inside Kubernetes, and then it handles that connection from Kubernetes back into the Azure portal. So HyperCore here is handling the VM operating system layer, and then of course the infrastructure. So providing that resilient, self-healing virtual machine workload infrastructure that you're familiar with on HyperCore, and letting you manage those legacy VMs as well as containerized appliances and applications right next to each other. But you get key capabilities like integrating those Kubernetes clusters that are on-prem into your Azure management stack. So things like GitOps, setting policies, loading extensions, log analytics, all those kinds of things can be done on remotely managed Azure Arc Kubernetes, essentially the same way that they could if these were actually running Azure AKS Kubernetes in the cloud. To kind of show what it looks like. So, yep.
Yeah, sorry, Dave. I was just going to say, it seems like with a lot of what we're presenting here today, Azure Arc and these use cases really blurs the lines between what's running on premises and what's running in Azure natively, kind of giving a single pane of glass across all those sites. They don't care if it's running on top of us or some other infrastructure out there. Is that kind of the case?
Yeah, that's definitely the case. And from in this case, we're talking Kubernetes from an application developer, they just have access to a Kubernetes cluster. They wouldn't necessarily even know or be able to see unless you expose them to that data where it's being hosted or things like that. It would look and act, from the Kubernetes API perspective, from the GitOps deployment perspective, just like any other Kubernetes resource. So it really does abstract the where, and could even over time allow those locations to change as necessary. Maybe taking what was a cloud-based Kubernetes deployment and moving it down to a data center or even an edge location.
Awesome.
So here, just a kind of a different view. So this was a K3s 3-node cluster running, and again, you can see it from. I show a couple different perspectives here. In the Azure portal, it shows up just like any other Azure nodes, and then from the Hypercore side, these are just virtual machines that have been provisioned, and this can all be done with automation using Cloud Init, as Craig mentioned, using Ansible collections to deploy and configure these Kubernetes nodes. Once they're up and running, Kubernetes to deploy the Azure Arc integration pieces, the operators, and you can see a little bit of those running here. And again, this is just regular Kubernetes. It just happens to be running on premises on Hypercore, but it's fully connected and manageable through the Azure portal. Another, probably maybe one of the most popular, but sometimes hidden kind of hybrid cloud strategy is leveraging cloud storage. And particularly when you talk about smaller edge locations or areas where you may not, need a bunch of long-term data archiving, services like Azure File Sync let you leverage cloud-based storage with the resiliency, with the capabilities, for archival, for long-term retention that it provides to automatically store and then archive any type of data. Have a local on-prem copy that's fresh and available quickly when you need it, but then archive it off to cloud-based storage to save on cost and basically provide kind of an infinite capacity file server. And then in some use cases, actually provide synchronization of data and sharing of data between multiple sites, between, cloud-based access and different branch offices, for example, or even distributing it out to, tens or hundreds or thousands of edge locations. So, high level, what it looks like is it actually deploys on a Windows file server. So you have your normal Windows file server, you deploy the Azure File Sync agents with the right credentials to connect it in, and then it will take that file share storage and start replicating it up to Azure file storage in the cloud. And then you can optionally enable that archiving piece that based on certain policies, like, hey, when my on-prem file server reaches a certain capacity, like it's 80% full, it can take the oldest files or largest files, and what it actually does is stub them out so they still are visible in their location, but they're actually taking up 0 bytes of storage at that point. If something does go and access them, they'll just be automatically retrieved down from the cloud, from the Azure storage, without anyone taking intervention. It'll just take a little longer to access those. So a lot of unique capabilities and applications for using Azure File Sync. Another kind of unique capability, and this combines Entra ID being used as an application proxy, is you can actually publish on-premises web-based applications, things that might be running in your data center or running out on edge locations, publish those as web-based applications that are proxied through Azure. And it's a pretty simple setup. You load an agent in one of your on-prem virtual machines that has access to those web-based UI. You publish the web-based UI that you want to have visible, accessible through the Azure portal. And then people with proper credentials, with proper authorization, can access those from a browser anywhere just by going to a particular Azure-based URL and without it requiring any VPN. And as I mentioned, another kind of common use case of hybrid cloud applications where you have pieces running on-prem, pieces running in the cloud, is in any type of IoT solution. In the Azure IoT Edge solution, there's several key pieces. One is the Azure IoT Edge component. That would be a device runtime that runs out on the edge, runs in a virtual machine, and it lets you deploy modules, which are actually Docker containers, as it turns out. So through the Azure portal, you can define Azure IoT modules, which is basically a Docker container. push those out to your edge runtime. And generally those would do specialized functions like, gathering MQTT messages from a particular piece of hardware, maybe doing some local processing of those, and then sending those telemetry, all that telemetry and resulting data up to the Azure IoT Hub. And that's all built in a single ecosystem that can be easily deployed and managed on hypercore systems, whether it's in your data center or whether it's in hundreds or thousands of remote edge locations. And again, we'll run through AWS is probably the next most common cloud that we hear about. We'll talk about some of the same types of services that exist there, but then also some unique ones. So in AWS, kind of the key piece that provides remote management is called AWS Systems Manager. And just like with Azure Arc, you can load a Systems Manager agent, register all types of different on-premises applications and systems up to the AWS portal. And then once they're registered, you can group the resources, visualize the data, take certain actions, whether it's operations management, change management, deploying applications, or managing characteristics on the particular nodes. One of the unique things that we see very commonly that leverages AWS Systems Manager is AWS ECS Anywhere. It stands for Elastic Container Services. And this is the same service that you can run on AWS to deploy ad hoc containers. With AWS ECS Anywhere, you can then deploy the ECS Anywhere agent on the edge in a virtual machine on Hypercore. And it's basically these steps. You activate ECS Anywhere, you create an activation key, you deploy the SSM and ECS agent. And this can all be done with automation. So I have Ansible playbooks and Cloud Init scripts that would automatically deploy these runtimes, register them up to AWS ECS Anywhere. Once you're all connected, then you just define your application containers and the resources need, and then you push out and deploy your applications to, again, any number of central or remote sites. And you can deploy applications here to both cloud-based resources and on-prem, whether they're, again, in a data center or distributed edge. So this would be their equivalent. They do also have a Kubernetes-based service, but one of the things that's nice is if you don't need the scalability of Kubernetes and multiple nodes, you just have containerized applications that you just need a mechanism for pushing out and updating. ECS Anywhere is a great example of a service that could do that for you. They also have their own storage gateway solution, so similar to Azure File Sync. This one is a little bit different, but it's the same benefit. It's actually, in this case, a virtual appliance, which is very nice. So from the AWS console, you can create a new gateway. It'll give you a virtual appliance to download that you just deploy that virtual appliance directly onto your Hypercore system. It boots up, it connects right back to AWS that has all the credentials to associate it with your AWS account. From there, you can create shares. They can be SMB, for Windows file shares. They can be iSCSI. There's tape library support. There's a bunch of interesting protocols that are available. And you also can have multiple gateways that are sharing the same data. So, for example, here I have a gateway called PM Westfield. It's got SMB file shares, but the storage that it's actually exposing is backed by S3 file storage in the cloud. And you can also leverage the full capabilities of S3, different kinds of S3 tiers and migration and things like that. So very powerful and easy to deploy solution. Another thing, because it's a virtual appliance, it's automatically updated by AWS. So when they have code changes or security updates, that appliance will get updated and have those pushed out directly from AWS out to your Hypercore systems. And then AWS also has their own IoT specific systems. They were one of the very early ones out there. Their most common solution is called IoT Greengrass. And it also can deploy a wide range of service. You can configure, there's the cloud component, there's the IoT Greengrass core device, which is what you would run on premises. Generally, it deploys into a Linux virtual machine. You can automate that. It can run all types of apps from containers to it functions as a service, Lambdas that they're called. So it actually supports quite a number of different kinds of workloads that can be deployed out on the edge, but it's really geared about data collection, local processing, and supports a wide range, but it all is manageable from the AWS cloud. And a lot of very robust services that are available through there. Other clouds here, just to kind of cover and touch on. Again, I said most of these services, most clouds do have very similar services to any of these. One we wanted to highlight here is Google, kind of the father inventor of Kubernetes. They have a service called Google Anthos Bare Metal Cluster. While it says bare metal, it's fully supported in a virtual machine. And it leverages their fully managed Kubernetes stack, which is called Anthos. So it's their GKE Kubernetes with a bunch of managed value-added services like their service mesh, function as a service, policy and orchestration. Is very easy to deploy on premises and have Google manage the updates for you through the Google Cloud. And then again, HyperCore, we handle the deployment of those virtual machines, of the OS, the initial configuration. And again, because while this is Kubernetes and you certainly can deploy a multi-node Kubernetes cluster on-prem, we do find that in a lot of smaller locations, it's a single node Kubernetes cluster that's on a resilience infrastructure that's already going to provide storage resiliency and failover is very, very simple to deploy and manage. And then again, here with this managed Kubernetes, Google will actually take care of updating the Kubernetes stack for you remotely. So some additional capabilities that are there. This is what it looks like from the Google Cloud platform. And I guess kind of a key here, as you can see, and this is similar to the way, Azure Arc, it just shows up as another Kubernetes resource in the Google console. So the first one here, this Edge Westfield, is actually deployed on-prem. The next one here is running in US Central 1 region on GKE. They look and act the same, and you have all the same configuration and deployment options available through Google. And then on the HyperCore view, again, it's a virtual machine. You have local access. You can, use your kubectl to, get right directly to the Kubernetes cluster locally. You can also use the Google resources to go through the Google platform to get to these on-prem Kubernetes resources directly without having to have local network access. So a lot of capabilities for your application developers who, in the end, this is what they care about, is being able to get to that Kubernetes API and their deployments. So again, to summarize, really our goal at scale is to provide cloud-like management for your distributed resources, whether they're at the edge in a centralized data center or running in other public clouds. Craig, other things to add, I guess, in summary here?
Yeah, I think it's interesting as we went through these, it's kind of a hodgepodge, a collection of services that are available to IT teams and partners that are putting together solutions of which we are just a part. And again, no matter where we fall on that spectrum of where these services are provided, you need to make sure that whatever tools have been chosen work alongside what you're bringing into the mix. And so as we're being brought in distributed environments or local data centers, the answer is almost always yes, we can work with whatever tool set they've already chosen. They've got a lot of really good examples with Azure. I think with that being the most common one that we see, that's the one we always talk about. But a lot of those same services that exist with AWS exist with Google, and just basically the assumption should be made that whatever services you plan or that you're being asked about from these cloud providers, can they work with SE platform? The answer is going to be yes.
No, absolutely. And and that's our goal, is to, provide that ability to integrate with the existing resources, the existing services, provide automation, which is really a key for everything going forward, both at keeping, all these sites themselves resilient, but also automation of deploying the application, day two, updating those applications and infrastructure, which is a key. And again, connecting into being part of your entire application ecosystem, wherever all the pieces need to be.
Perfect. Yeah, I know we've got a lot of additional details out on our website, scalecomputing.com. You can find that. Just go through the specific solutions with whichever hybrid cloud services you're looking at and how that works along with us. Whether that's videos, white papers, whatever you can find there. And then also feel free to reach out to us with questions, and be happy to answer anything that we can to point you in the right direction. So thanks for joining us today.